The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and thank you for taking time out of your schedule to join us today for our webinar from ELK Products on the M1 system, solutions for serious security and automation professionals. Today's webinar is going to be about an hour long, and you should have on your screen a questions pane. If you have any questions during this time, please feel free to type those in. Assisting me today is Amy Strickland, and she'll be monitoring those questions at any time. She may stop us so that we can go over a particular point or something during today's presentation. But for those that were able to join us at CEDIA last week, we certainly do appreciate you taking time to stop by and visit. We certainly appreciate getting to meet everyone there at CEDIA last week. So if everyone is ready, we're going to get started with today's presentation on the M1 system and why ELK is the smart choice for installers and integrators. So what makes ELK different? Well, our products. ELK products, we've been in business since 1996. We have a lot of accessories for the security and low voltage industry, as well as our M1 security and automation controller. A lot of our products, we really feel like we produce high quality products, giving you the ease of installation and reliability, better warranties on our products. A number of our products include limited lifetime warranties on them. Our M1 system carries a 2-year warranty with the exception of a couple products like the Navigator keypad, which is a 1-year warranty. Our people here, if you contact us here in Hildebrand, North Carolina, usually you're greeted by a live operator. Very little hold time, and I'm very proud of our tech support team that we've had a number of awards over the years. So very proud of them and what they're able to do to help our installers in the field answer questions, resolve issues, and so forth. Today's discussion is going to be about the M1 control and how we feel like it's an uncompromising security and life safety system, giving you secure connectivity with a lot of the popular smart devices these days, providing you a flexible and intelligent automation controller. Great for residential, business, fitness centers, schools, a variety of applications that the M1's been used in over the years, some of which you probably never really considered. The M1 is basically it's a programmable logic controller. Its inputs, its output, its rules. So it can be used in a variety of applications beyond just a traditional residential security and so forth. What makes the M1 different? Well, like I said, we've been doing security for a number of years. We really put a lot of emphasis on security and life safety, but certainly we put a lot of emphasis also in providing you with a platform that has high-level encryption, multi-levels of authentication in our process, our controller, our wireless devices, and so forth. Providing you a flexible system, allowing integrators to work with a number of industry partner manufacturers for lighting, thermostat control, AV, access control, and so forth. Keeping the system expandable and scalable to fit the variety of applications and needs. It's a modular system, so if you don't need all of the features, you can purchase just a base system and then add to it as the project grows or as the budget allows or demands from the consumer demands that the system to be added onto. You can certainly do that with an M1 system. Keeping our system easy to program, but still providing you a very powerful rule writing engine. Keypad programming, very English text, easy to read and follow, but the RP2 software certainly makes programming simple. And like I said, offers that very powerful rule engine to create that automation and customization for our customers. Providing you with remote access to the system, a lot of which doesn't require any type of monthly monitoring or service fees, certainly putting you in control of your recurring monthly revenue and charges to your clients. Some features of an M1 system. On board, there are 16 zones. The system is expandable up to a total of 208 zones. Of that 208, 144 of those can be wireless. There are 13 onboard outputs, expandable up to 205 total outputs. We can support up to 199 users. We offer 6 different levels of arm state. Voice announcements, the M1 has a 500-word voice vocabulary built into the system. We'll support up to 8 areas or partitions. You can add up to 16 keypads to an M1 system. We have a 512 event history log. Over 40 different integration partners are working with the M1 system at this time. A built-in astronomical clock, optional two-way listen-in primarily for alarm verification from your central monitoring service, as well as a very powerful 2.5 amp power supply. And we are UL listed for residential burg and fire and commercial burg, home health care. What we're looking at now is our keypads. We have several different styles of keypads, touch screens, and arming stations to select from. You can have up to 16 of these connected to the M1 system. The voice alert capabilities of an M1, like I said, it has a 500-word voice vocabulary built in. Any zone can have a 6-word phrase assigned to it through the vocabulary, and that's all 208 zones. You can also have the system enunciate when it's arming, when it disarms, when a visitor comes to your front door. Temperatures, we offer several different options for temperature enunciation, either from the larger keypad, the KP and KP2, those are the 2 bigger keypads, have built-in temperature sensors to monitor the ambient temperature around them, as well as another option we'll talk about in a second called our zone temperature sensor. You can set the system up to enunciate, say for instance, non-alarm zones. Maybe it's a door or a gate or something leading into a restricted area. Not really necessary to have it cause an alarm condition, but certainly you want to be notified when that zone opens. You can assign those zones as a definition 16 for non-alarm and then assign a voice description to them. What are some things that can be integrated with an M1? Security and life safety, one of our top priorities. That's kind of the backbone of the M1 system, but certainly we can do some access control, lights, fans, thermostats, window coverings, garage doors, water heaters. We have a electric solution for automating a water heater as well as a gas solution for gas water heaters. Water shutoff, sprinklers, pumps, basically anything electrical that you can control through a relay or perhaps a lamp or an appliance module from one of our integration partners. Certainly the M1 should have some sort of capability of being able to integrate with that particular device. The alarm reporting capabilities of an M1 system, we have the built-in telephone dialer, which supports the industry standard contact ID, SIA 4+2, and so forth. We offer optional two-way listen-in for the M1 system, primarily for alarm verification or customer convenience. Customers can actually dial into the system to access the two-way capabilities, maybe perhaps check on a loved one, or just to listen in with the residents. Now, this would be for standard POTS line connection. IP reporting and cellular reporting with our C1M1. That's our dual path communicator, super fast, full data communication to your central monitoring station over IP or the cellular pathways. We also have an IP reporting solution through the XEP. That's our standard Ethernet interface, and that's compatible with the DSC SureGuard or the Osborne-Hoffman 2000E central station receivers. We also offer cellular communication through dial capture devices, for instance, Uplink, Telguard, and others, as well as integration to the Uplink 4500EZ and the AES and Telenet radio. And that uses our M1X SP. That's our serial port expander with special firmware update. Talking just a little bit more about the C1M1, this is our dual path communicator. It ports over IP primarily, but if the internet should happen to be down, it's going to automatically revert over to cellular. There's no dial capture, there's no data bus decoding, no cloud server, so it's really a super fast communication between the M1 and your central station. We offer secure, hassle-free connectivity for remote programming of the control, as well as several apps are available for arming and disarming notifications. We offer two versions of the C1 M1. We offer our 4 GSM and our LTEV version, depending on which carrier is stronger in your area. Now, if cellular reporting isn't something that's really necessary for this location, then I would suggest the M1XEP. This is our regular Ethernet expander. Now, this supports IP reporting over the internet to the SureGuard 3 or the Osborne-Hoffman receiver. Also allows for secure connectivity and remote control over the internet, as well as being able to set up email and text notifications. Supports integration through a number of apps and interfaces. Quick background overview of the apps that are currently available. The first one we see here is called ElkLink. Now that's available through the C1M1. Very basic. It allows for arming and disarming and viewing of the history. It is a free app and it's supported through the Android and the iOS platform. We have eKeypad Pro from an integration partner of ours that works through the C1M1 and the XEP module. M1 Touch Pro, which works for the Android platform. Connect One is a partner manufacturer of ours that's done a very good job at increasing the capabilities of an M1 from a standard standalone system. It is a cloud-based service. It is supported through the XEP module, and what they've been able to do is enhance the capabilities of an M1, primarily for larger installations, which may require networking multiple M1s together, or logging capability, enhanced email capabilities, and so forth. There is a monthly service charge for their automation software, but if you have a larger facility or campus or something along those lines where you need increased user base, networking multiple M1s together, I would certainly suggest taking a look at Connected Technologies and their Connect One automation software. And we have Planet M1, which is a cloud-based service that's supported through the XEP. And then M1 to Go, which is our automation software to run on your PC. No charge for M1 to Go, and that is supported through the XEP module. Talking a little bit more about the access control capabilities of an M1. I like to call it Access Lite. It's not a full-blown access control system, but it offers a lot of nice features and benefits, not without the high cost of a full-blown access control system. We can support up to 16 doors or gates, 26-bit Wiegand readers or biometric readers. The history logs when a user presents their card, code, or biometric read at the reader. And like I said, there's also some enhanced features through Connect Technologies and their Connect One software. The ease of programming with our system, the keypad programming, very easy to navigate English text. You can basically set up everything security-wise with the exception of assigning the voice descriptions and creating the automation aspects. You can basically do everything else through keypad programming. However, I think once we see the RP2 software and how simple it is to navigate, I mean, basically if you can check a box, use the drop down, enter a description, you pretty well mastered the software, and then you still have the powerful rule engine in which you can create those customization and automation features using our whenever and then statements. We're going to look a little more about the software at the end of today's presentation. Now, before we get into the M1 Gold, the main board, the hardware and board layout, and some installation tips, Amy, do we have any questions yet?
We have, a question we get asked a lot about the presentation, and we will be providing a follow-up email after the presentation. You'll probably get that sometime tomorrow. That's going to have a copy of the presentation PowerPoint that you're seeing here today, as well as a link to a recording of the webinar and some other resources that you may find helpful. The other questions that I've been asked is pretty specific, and I'm going to have to do some research to get an answer for that. So we'll carry on for now, and I'm sure other questions will come in.
Okay, certainly do appreciate that, and I do apologize for not mentioning that earlier in the presentation, that there would be a copy available, like Amy said, tomorrow, the next day, with this information. All right, so let's get started with the M1 Gold system and hardware overview. First of all, I would like to say that our system is available in kit forms. We offer several different kits available depending on the style keypad, or if you'd like to have a wireless receiver, our ELK 2A wireless receiver, or simply a kit with no keypad or no enclosure. So we give you options there to select from. Now, depending on the application, you may decide to go with one of the kits without the enclosure, so you can add our ELK SWB28. That's our 28-inch enclosure. It's 14 wide by 28 tall. The regular enclosure in these kits that we're seeing here on the top three options, and this one here in the lower left-hand corner, that's the ELK SWB14. It's a 14 by 14 enclosure. Typically, if somebody would like to know, well, what can I do with the 14-inch enclosure, I would say if you're doing a totally wireless system, that enclosure would be fine, because the wireless receivers are part of our data bus, so they can be remotely located. Or if you're doing perhaps up to a 32-zone hardwired system, the enclosure would be sufficient. Beyond that, I would probably suggest going with the 28-inch enclosure, or just to future-proof the installation, the 28-inch enclosure would be a good solution for that. All right, the M1 main board is what we're taking a look at right now. The green terminal blocks here on the left and the right-hand side are called Phoenix connectors. They are removable. So in a worst case scenario, for some unknown reason or catastrophic something happened, if you needed to remove the M1 board, you wouldn't have to disconnect any wiring except for the battery leads. You could take the terminals off, replace the main board, connect with your computer, and be back up and running in just a very few minutes. The upper left-hand side, the first two terminal blocks, are our 16 on-board zones. Below that is the AC input and auxiliary DC voltage outputs, the master on-off switch, the battery leads. The bottom of the enclosure, there's a white barcode sticker that contains the serial number for the M1. That's a unique number. It's an 8-digit number starting with 0. No two M1 serial numbers have ever been duplicated, and you'll need that information once we get into the RP software in order to connect to the system. You can also obtain the serial number through keypad programming as well. The upper right-hand corner is our telco connection, standard POTS line connection there. Below that is the RS-232 on-board serial port. We call it port 0. Below that is a white header pin that we have called J16. This is your low voltage outputs 7 through 16. Next, outputs 1, 2, and 3. And the last one is our data bus, our RS485 data bus. Now we're going to talk a little bit more about each one of these in the next few slides. The zones on an M1 system, each zone can be configured with the end-of-line resistor, which is a 2.2K, or they can be configured normally open or normally closed with no resistor required. That's optional per zone. That's not a global setting. Now, the purpose of the end-of-line resistor is to provide supervision of the wiring from the panel out to the device. So the resistor should be at the device itself for proper supervision of the loop. If it's not possible to get the resistor at the sensor, you can simply leave it out of the installation and configure the zone normally open or normally closed. Now, there are some devices that require the resistor. Smoke detectors, for instance, is one of them, so you would have to incorporate the resistor with the detector. So giving you that option of not having the resistor, if you can't get it in the location where it does the most good for proper supervision, you do not have to put it at the panel. If it's at the panel, it's not really doing the job it was intended to, and therefore it's the loop going from the zone to the device could still get shorted, and the panel would not know that that particular device is no longer active. So end-of-line resistors at the sensor, or if that's not a possibility, then you can omit them and configure the zone normally open or normally closed. Any zone on an M1 system will support 4-wire smoke detectors, 12-volt DC, 4-wire smokes, the main board as well as our hardwired input expanders. You can connect your 4-wire smokes to them. Only zone 16 will support a 2-wire smoke loop. Those detectors must be listed on page 6 of the installation manual to make sure that they are compatible with an M1 system. So if ever in doubt, refer to page 6 for compatibility for 2-wire smokes. They do require a different resistor. It's an 820 ohm. There's a special jumper right below zone 16 called JP1, which selects between normal versus 2-wire. Now you can have up to 20 detectors daisy chained together. So you can have one loop with 20 detectors, but I think you'll find 4-wire smokes more versatile. Any zone can be configured as a 4-wire smoke. You can basically use any 12-volt DC 4-wire smoke from any manufacturer. So that makes them more versatile, individual points of contact, and give you a wider range of selection as far as which manufacturer to use. Now, besides being able to monitor window, door, motion, glass breaks, and smoke detectors and so forth for security, we also offer temperature sensing capabilities. We have our M1 ZTS. This is our zone temperature sensor. It has the probe built into the housing. This is a very small, compact unit here. Fits nicely on the wall. Doesn't take up much space and doesn't look bad. Looks just like a thermostat housing. We also have the M1 ZTSR. The R for remote probe, 7-foot cable with a stainless steel probe on the end of the cable. These are great for monitoring the ambient temperature, say in a server room, commercial cooler or freezer, maybe a wine cellar, animal habitat, simply anywhere where our customer would like to know what the actual temperature is in that area. So using their apps, the eKeypad, M1 Touch, M1 To Go, and so forth, they can connect, log in, see what the temperature reading is in those areas. We can monitor between -50 to 120 degrees Fahrenheit. Now these connect to the main board only. So that's zones 1 through 16. You can have a maximum of 16 of these sensors monitoring 16 different environments. You can write rules to have things happen when the temperature gets too hot or too cool in an area. So turn on a fan, turn on a heater, open the blinds, adjust the vents, and so forth. Very versatile little units here as far as monitoring temperature, giving you feedback through the apps. Beyond the 16 onboard zones, we have our M1XIN. This is our hardwired 16-zone input expander. You can have up to 12 of these connected to the data bus, which will give you an additional 192 zones. They can be located at the panel or they can be remotely located. They are part of the data bus, so that gives you the versatility of being able to remotely locate the input expander and then hardwire your sensors to it and so forth. The dip switches on the board, the blue dip switches here set the address. That address will determine the starting zone number. For instance, address 2 would be zone 17 through 32. Address 3 would be 33 through 48 and so forth. Now, besides hardwired capabilities, the M1 also has wireless capabilities, and we can support up to 144 wireless zones. The M1 has a total of 208 zones. Out of that 208, 144 of those can be wireless. We offer our ELK two-way wireless advantage. Now, this is a true two-way encrypted communication. We use a frequency hopping type scenario where we work with a 192 to 128 megahertz frequency. That allows, it's harder to detect and jam that constant changing frequency. Another unique feature of the ELK two-way wireless is the ability to synchronize the sounders in our smoke detectors to give you status feedback from our key fobs, as well as we have an indoor motion detector with a bright white courtesy or convenience LED built into it. So what we offer in our ELK two-way line, we have our ElkRP2 This is our transceiver. The reason we call it a transceiver is not only can it receive signals from the wireless devices, it can send signals as well. Now this, when you're connecting the ElkRP2 to the M1, the first one has to start at address 2. You can have a maximum of 4 transceivers on the data bus. Still a maximum of 144 wireless zones, but the addition of additional transceivers allows you for more coverage area. So if it's a larger home, or maybe you suspect a weak signal strength area or something along those lines, you can add additional transceivers to help increase the coverage area. We offer a slimline window door sensor, the 6020. A mini window sensor for non-metallic surfaces, the 6021, a universal 3-zone sensor. Now that has the built-in read and magnet, as well as the option to hardwire 2 additional contacts. So it is a true 3-zone sensor. Our 6023 is our recessed window door sensor. 6030 is our indoor motion, also available in a pet immune version, up to 40 pounds, the 6030P. The 6032 is an outdoor motion sensor. We have our 6050, our sound all smoke detector, 6051 carbon monoxide, the 6040 glass break, and then our 6010 and our 6011 fobs. Part of the two-way status feedback from an ELK two-way product line, for instance, we have our 6010, our regular 4-button fob. We have the inquiry button, or button 3 here. When you press button 3, if the LED here at the top lights up solid green, system's disarmed. If it lights up solid red, system's armed. If it's flashing, the system has been in alarm. So from an end user standpoint, if they are not certain they arm the system after walking out the door, they can press the inquiry button. Lights up solid red, yes, they remember to arm the system. Coming home in the evening, if something doesn't quite feel right, maybe an uneasy feeling, if they press the inquiry button and that's flashing red, they know their system has been in alarm at some point. So that would alert them as whether or not they want to enter the premises. All of the other sensors have a built-in bicolor status LED built into the sensor. Maybe a little hard to see, but it's in the center of our 6020 here. When I remove the magnet from the sensor, if this LED lights up green, the communication was acknowledged. The transceiver got the message, turned around, sent a signal back to let the sensor know it was acknowledged. From an installation standpoint, if you're not quite certain, one transceiver is going to cover the residence or the facility. You can mock up an M1 with one transceiver, and as you're walking around to the prospective area where the sensor is going to be mounted, you move the sensor away from the magnet, lights up green, it got acknowledged. You know it got through. You move down another room or two, same scenario, you get the green acknowledged, you're good. At the back of the residence, it's red, so you know you're out of range at that point. Another feature, and if it is out of range, you may want to relocate the transceiver more centralized or add additional transceivers to the data bus to help increase that coverage area. Another feature that ELK has built into our M1 system is what we call the walk test mode. If you have a speaker connected to output 1, which is for interior speaker and siren, if you have a speaker connected and you're in walk test mode, as you move this magnet away from the sensor, you get the green LED. The system will also speak a level from 1 to 8. That's the total number of data packets. 8 being the maximum. So as you're walking and testing, you hear 8, 7, 6. That's good. That's a good, strong signal. More towards the middle or the back of the residence, you're starting to hear 4, 3, maybe 2. Signal still got through, but it's a much weaker signal at that point. So once again, relocate the transceiver or add additional transceivers to the data bus to help increase that coverage area. Our 6030 and 6030P have this nice bright white courtesy LED built into them, and this can be turned on during certain events, so it can flash during an alarm, or it can simply be programmed to turn on like when the entry delay starts and so forth. I think I have a couple rule examples to show you a little bit more how that would work. We'll take a look at those when we get into the rules. The 6050, this is our sound-all smoke detector. It has an 85 decibel sounder built into it. When this detector goes into alarm, it sends a signal to the M1. The M1 will then send the signal back to turn on the sounder. That it will also turn on the sounder for any other 6050s which are programmed into the system. Likewise, if the M1 should go into alarm, either from a hardwired smoke detector, 2-wire or 4-wire, or a panic key on a keypad is pressed, it will then send that same signal. So now you have all of your 6050s with their 85 decibel sounder going into alarm during a fire alarm condition. Besides the ELK two-way wireless, we also are very fortunate we can integrate with 2 other different wireless technologies. We offer the M1X RF EG receiver to support the Interlogic's GE 319.5 megahertz frequency. And we have the M1X RF2H. This supports the Honeywell, the 5800 series transmitters. So if you have an existing system, maybe you're taking out an older system to replace it with an M1, they currently use either GE or Honeywell. Very possible you may be able to reuse those sensors and just simply incorporate either our XRF EG or the XRF2H receiver in the data bus, and you reuse those existing wireless sensors. Now, new to ELK is our new 319 series. This is a very dependable, economical, versatile type sensor. It works with the ELK XRF EG receiver for the 319.5 megahertz, but it's also compatible with other manufacturers that support that 319.5 megahertz as well. We have a window door sensor, we have a heat rate of rise, a couple of very nice fobs and so forth. If you need more information on those, you can visit our website at elkproducts.com and see a complete list of those new 319.5 megahertz sensors we offer. Now on the left-hand side, the last green terminal block is the power connection. The first is the plus S aux terminal. This is your switched output for your 4-wire smokes or any other device that requires that momentary power interruption. Below that is the VAUX for your for your power devices that do not require that momentary interruption, say for your motions and glass breaks. The AC terminal for our TRG 1640 transformer. The master on-off switch does both the AC and the battery, so no need to disconnect any wires for maintenance or troubleshooting or to install new equipment. All you have to do is move the on-off switch, and that does both the AC and the battery. The battery connections on an M1 will support up to an 18 amp hour sealed lead acid battery. The system will give you 1 amp of continuous output at any given time, and that's a combination of the SOX, the VOX, J16, and the data bus. So at any given time, the M1 has 1 amp continuous output. When the system goes into alarm, you can get up to 2.5 amps of current out of it with the additional current coming from the battery. Now, for those installations that require more power, we offer the ElkRP2 Remote Power Supply. This is a 12-volt DC 2 amp power supply. It's perfect for those larger installations. It can be supervised over the M1's data bus. Basically, it takes up a keypad location, so you can get notified of AC fail and low battery, as well as there's a programmable output on board that you can use with our rule engine. For instance, in a access control application, this would be perfect to power your maglock or your electric strike, and use the output and the rules to open and close that contact to control that maglock or electric strike. It does require its own separate transformer and battery, not included. Now, like I said, this can be at the panel. It can be remotely located on the data bus. It can be a standalone power supply as well. It doesn't have to be used with the M1. It's just a great 12-volt, 2 amp power supply with master on-off switch like the M1, as well as a relay output for AC fail and low battery condition. Telco connection. This is just standard line seizure connection, tip and ring from the incoming phone line, R1 and T1 out to your house phones. We give you an ELK 952 surge suppressor in the kit, and we try to make it as easy as possible to incorporate that surge suppressor to add that additional protection to the phone circuitry. Right below the telco connection is the RS-232 serial port that's built onto the M1. We call it port 0. It actually has 3 purposes, but can only do one thing at any given time. You can use this to direct connect with your PC for programming using the RP2 software. So using either a USB to serial adapter or a standard serial cable from your computer to the M1, you can plug directly in for programming. It is also possible to connect the C1 M1 or the XEP module to the port and then access the system over the local area network or through the internet. In the left-hand side picture, this is our C1 M1 connected to serial port 0. In the middle picture here, this is the XEP connected. Now the XEP comes with its own white ABS plastic housing, so it could be outside of the enclosure, or you can use the ELK SWG. That's the circuit glides, the gray circuit glides here, which allow that XEP to be removed from its housing and then incorporated into either the SWB14 or the SWB28. Now the onboard outputs, the first one, output 1 is for your interior speakers. This is where the voice enunciations are produced, as well as the interior siren sounds. You can have multiple speakers connected to output 1 as long as you keep the overall load between above 4 ohms. We offer a number of different 8 ohm speakers that work fine with the M1, or you can use our SP12F. That's a 32 ohm speaker that actually fits into a single gang electrical box. You can have 8 of those in parallel connected to an M1 and still keeping the overall load above 4 ohms. Output 2 is a supervised siren output, typically for exterior devices, your exterior speaker, or you can convert output 2 into a voltage output, which would be 12 volt at 1 amp, so it's capable of driving a self-contained siren as long as it doesn't exceed the 1 amp rating. If you're not using output 2, if you're not going to have anything connected to that terminal, you need to make sure to put a 2.2 k ohm resistor across output 2 positive and negative to prevent the output 2 trouble condition, just like we have in our picture here. With nothing connected, we want the resistor there to satisfy the supervision to prevent the output 2 trouble. Output 3 is a general purpose Form C relay. So it's capable for dry contact, maybe for a overhead garage door to simulate that button press. Or you can control voltage devices up to 24 volt DC at approximately 4 amps. To control output 3, we would use the RP2 software and create a rule to turn that output on and off. The J16 connector right up here at the top of the picture. These are our low voltage outputs 7 through 16. Each one of these is positive switched 12 volt at 50 milliamps each. They're certainly capable of driving low current relays, piezo sounders, LEDs, things of that nature. We offer the M1RB relay board, which connects to J16, and that will convert outputs 9 through 16 into actual Form C relays. You still have 2 low voltage outputs, 7 and 8, but with the M1RB, we now have physical dry contact relays, 9 through 16. These relays are capable of switching up to 120 volt at approximately 8 amps. So they're beefier relays for controlling higher current loads. For greater expansion, the M1, you can have up to 205 total outputs. We offer the M1 XOVR. This is our 8 relay and 8 low voltage output board, connects to the data bus. So it can be remotely located. If it makes more sense to have the XOVR in a mechanical room or where the solenoids for the sprinkler system are located, you can certainly do so. By taking the M1RB and connecting it to the XOVR, you now convert the low voltage outputs into actual Form C relays. So with the addition of these 2 boards here, the XOVR and the M1RB, you now have 16 physical Form C relays connected to the data bus. Now, a little more about, now these are the keypads that currently support having a prox reader connected to them. The readers do not connect directly to the M1 or to our little brother, the EZ8. They connect to the back of a supported keypad. We have the M1 KP and KPB, the B for the blue display. The readers, we also have the KP2, the KP3, and our CAM module, the M1 KAM. So these are the devices that the 26-bit Wiegand readers can connect to. The CAM module basically takes a keypad location. You can wire the reader directly to the CAM, and it also has the relay output for controlling your electric strike or your mag lock, as well as a request to exit input. So you can have a maximum of 16 keypads, maybe one regular keypad, 15 CAM modules if you're doing a lot of access control. But remember, there's also Connected Technologies, which has done a great job at increasing the access control capability of an M1 system. And we're also very fortunate that the M1 is compatible with a number of different partner manufacturers. And if you visit our website at elkproducts.com, click About, and look for integration partners, you can get a complete list. This isn't a complete list. This is kind of an overall view of some of the capabilities of an M1 system, which includes Z-Wave integration through our XSLZW, which talks to the Leviton interface. Now, this allows you to do Z-Wave lights, thermostats, and locks from the one interface. We also have Lutron integration for our Radio Raw 2 interface for Radio Raw 2 lights, thermostats, and shades. The Homeworks QS and RA2 Radio Raw 2 Select and Caseta lighting integration. UPB lighting integration, Insteon. Also, the XSP, our standard serial port interface, allows you to talk to a number of different communicating thermostats, so Air, Carrier, Leviton, RCS. Now, the final connection on the M1 in the lower right-hand side is the data bus connection. Now, our M1 data bus is a true RS-485 data bus. That supports our keypads, up to 16 keypads, our input expanders, our wireless receivers, the output expanders, the serial port expanders, the supervised power supply, the 212S, and the access control module, the M1 KAM. You can have all of these devices connected to the data bus. Each device has a different type as far as the way it's defined on the data bus. For instance, keypads are type 1 devices, input expanders are type 2, output expanders are type 3. Each board gets its own unique address using dip switches to set the address, or in the case of the keypad, you set the address at the keypad itself through programming. It is absolutely possible to share addresses as long as it's two different bus types. For instance, a keypad address 2, a wireless expander address 2, and an output expander address 2 are perfectly fine. They enroll just fine because they're different bus types. With the RS-485 protocol, you can have a maximum of 2 home runs connected to the data bus. You can daisy chain devices going from one device to the next and so forth. And according to 485 protocol, the data bus must be terminated. Now, that process of terminating the data bus means installing a 120 ohm resistor across data A and data B. We have built that resistor into our products already, so you don't have to worry about carrying another resistor with you. It's actually built into the product, and you engage the resistor by installing a black jumper in the appropriate location. For instance, the M1 main board, the JP3 jumper here in the upper portion of the picture, when that jumper is across those 2 pins, that engages the 120 ohm resistor across data A and data B at the panel. For 2 home runs, like in our picture here at the bottom, if we have 2 home runs, which we daisy chain devices together, the last device on each home run would have that black jumper installed. That would engage the 120 ohm resistor. In this case, the panel, JP3, would not be terminated. Now, the purpose of the resistor is for balance of the bus, to help prevent any corrupt data from getting onto the bus. It's part of the 485 protocol for no more than 2 home runs proper termination. Now and not to exceed a total of 4,000 feet when daisy chaining. Now, if we were to power down the system and measure the resistance across A and B here at the panel, we would read between 60 and 70 ohms. It puts the two resistors in parallel. It's kind of a troubleshooting tip that tech support may ask you to do if you call and say, I'm having a data bus issue. We may ask you, well, let's check the resistance. 60 to 70 is good. If it's more than 120, you're missing a jumper. If it's less than 40, you may have one too many jumpers, which could be a problem as well. So it's just a matter of making sure that we get the data bus configured correctly. Now, this is an example of daisy chaining. There's also two other options to wire for the M1's data bus. If you're not a fan of daisy chaining, if you would prefer to home run back to a central location, we offer the M1 DBH. Now, this is for new installations. It requires a Cat5 or a Cat6 wire from the hub all the way out to the device itself. And then you terminate the end with an RJ45 connector. Now, we're using 6 of the 8 conductors inside that cable. We're using 2 of those as a return path, one for data A, one for data B. Because we've incorporated, and this hub basically does the daisy chaining for you. So you don't have to worry about doing that in the panel. And you've made a nice, neat, clean installation using the DBH. Each home run must then be calculated as doubled because it incorporates the return path. So now we have a total of a 2,000-foot overall data bus using the DBH. You'll notice there are 9 ports on the DBH, and the DBH hub includes an RJ45 connector that has the resistor built into it here. You can see it here in our picture in J3. And as you add devices to the hub, you simply move that to the first available unused port. And that way you don't have to worry about terminating in the field. There are 9 ports on this hub, but don't think you're limited to 9 bus devices. You're not. You can have 2 of these hubs in parallel. That would be your 2 home runs. Or you can daisy chain the hubs together. So you can have 16 keypads, 12 input expanders, 12 output expanders, and so forth, 7 serial port expanders, all connected to the M1 data bus at any given time. The next option is more of a retrofit installation. This is the M1 DBHR. This is for retro with multiple 4-wire home runs. The retrofit board has 4 RS485 data buses built into the retrofit hub. Each one of these RS485 branches follows the same stipulations, no more than 2 home runs per branch, and each one must be properly terminated. Maybe a little hard to see, but there are several jumpers right up here which actually terminate the RS485 data bus, just like on the M1. This is an active device. There's a tremendous amount of information being transferred from each branch back to the M1. So it is very important to make sure that the distance from the input here to the M1 is as short as possible, making sure it's in the same enclosure. And you can have up to 2 of the retrofit hubs in parallel with each other. Like I said, this is an active device, a lot of information being transferred. We keep that distance as short as possible. You can have 2 home runs per branch, proper terminating each branch using the included jumper. This is what a typical wiring scenario would look like if you're using the M1 DBH out to, say, a keypad. We have our RJ45 connector. At the wiring harness on the keypads, you'll have 2 wires under data A. You have your orange and your green. The orange is data A. The green is the return path. For data B, we have white-orange for data B, and then the white-green is the return path for data B. For a device with screw terminals, you simply land your solid orange and solid green under data A. The data B would be your white-orange and white-green connection. Any questions about the data bus? Little different wiring solutions for the M1 data bus, all three of which are outlined very nicely on page 12 and 13 of the installation manual. So you have three methods. You can daisy chain, no more than 2 home runs. You can daisy chain devices. The DBH hub for Cat5, Cat6. Or you have the DBHR, which allows you multiple 4-wire home runs. Questions, Amy?
Yeah, one question related to the data bus is regarding the distance, and I know you had mentioned the 4,000 feet, but can you elaborate a little bit more on distance and you know, talk about distance in, you know, one direction to one device? How far out can you go as long as you're within that 4,000 feet? What's the longest distance that you can be from the control to any single device?
Sure. If you're daisy chaining, from the M1 to the furthest point could be a maximum of 4,000 feet. And it doesn't matter how many devices you have connected as long as you don't exceed 4,000. Now, power, you probably wouldn't be able to run power that far. So at some point you may most likely need a secondary power supply. If you're doing 2 home runs, you know, you say a maximum 2,000 feet per home run in that scenario. If you're working with the M1 DBH, because we're using 6 of the 8 conductors, the overall length, the combined overall length of each home run should not exceed 2,000 feet in that case. With the retrofit hub, each branch, each 485 branch there follows that same 4,000 foot stipulation. So each one of those should be able to support up to 4,000 feet each.
Okay, thank you.
Sure.
We have a number of other questions, but they're not directly related to data bus, and I think you wanted to get to some RP stuff, so maybe if we have a little time at the end.
Okay, sure. Yeah, absolutely. Okay, we're going to take a slight quick quiz here. We're going to give everyone time to look at this example here. And in this particular example, if we have a single daisy chain run directly from the M1 out to, say, 2 keypads, for example, where would you install the terminating jumpers in this scenario? That's a single home run, 2 devices. So we would want to make sure to install the jumper on A at the panel, JP3, and then the last device would be terminated. Now this length from M1 out to this last keypad could be that maximum 4,000 feet. The next example we have is 2 daisy chains off the M1. This is using just regular 4 conductor. So the top one is our 2 keypads. The bottom one is, we'll say these are input expanders we've daisy chained together. In this case, the M1 is in the middle. We have our 2 home runs. The last device on each home run would have the terminating jumper installed. Overall, added up, the total length of both of these should not exceed 4,000 feet. And if we were to power down and measure the resistance across A and B here, we should read between 60 and 70 ohms as a good rule of thumb. If we're using our DBH hub, the M1 DBH, which uses the Cat5 or Cat6, we have 5 devices connected. They're connected in J1 through J5. So with the single DBH hub, we would make sure the panel is terminated, and then the RJ45 connector is installed in J6. If I added another device, I would move that terminating jumper to J7 and plug my new device into J6. and so forth. And remember, we can daisy chain these hubs together, so don't think you're limited to only 9 devices. You can have multiple hubs daisy chained together. In the case of the retrofit hub, if we consider each branch as its own independent 485, just like the M1 main control, in this example, we have just the one hub. So we terminate the main control, JP3. We terminate the hub itself. This is JP1. Branch 1 is a daisy chain of 2 keypads. We terminate the last keypad and the branch. JP2 is assigned to branch 1. Branch 2, 2 home runs. The last device on each home run would be terminated. In this case, the branch is in the middle, so it would not have a terminating jumper. Branch 3 follows that same scenario, the last device on each home run, but not the branch. And then finally, branch 4 is a single device, so it's terminated as well as the branch itself, JP5 here. Power down, measure across A and B. We should read between that 60 and 70 ohms across each one. Now that doesn't necessarily mean, that means we're seeing the proper resistance. A and B could still be reversed and we would still not be able to enroll the devices. But it's just kind of a quick and easy way for us to first eliminate maybe a broke wire. If you know the jumpers are in the right place, you're still reading 120 and your device won't enroll, very possible we could have a broke wire, a loose connection. If you read less than 60, we know we have too many jumpers, which can be a problem as well. So it's kind of a quick and easy way to do a little troubleshooting on the M1 data bus. So before we get into RP, any other questions? I know we're running just a little bit over, and I do apologize, but I want to get into the RP software just real quickly.
So we did have a couple of other questions. We had a question about wireless range, and we talked about 2 different, types of wireless that ELK offers, but can you just give us a general answer on wireless range?
Sure. It's a very common question. Now, open air line of sight is we're with the industry, most industry manufacturers, 300 to 500 feet open air line of sight. It's kind of hard to put a definitive answer because a lot goes into construction material. Is it wood, stucco, stone, steel, things of that nature, which can degrade the wireless signal. So it's kind of dependent on the environment that the wireless is going into. So, I mean, a rough guess would probably be around 100 foot from the receiver or transceiver. But you have the option to do the signal strength test, the walk test, with the sensor, so you can get kind of an idea of how well that signal strength is. And you can have multiple transceivers or receivers on the data bus to help increase that coverage area.
Okay, another question that we had was related to the auxiliary power supply, and that was the 2 amp power supply that you were talking about, and it uses its own battery and transformer. Can you tell us the type of transformer that it uses and the maximum size battery that supports?
Yeah, the transformer is the ELK TRG1640, and you can have up to a 12 amp battery connected to the 212S power supply.
All right. And another question that we had was related to the C1M1 and integration with some of the software partners. I know on the XEP slide we saw some, logos of those partners that it could work with. And the question is about, what the C1M1 will support.
Sure. It supports the same partner manufacturers connection over the local area network on the non-secure port 2101. So it'll work with those as well.
Okay, great. Thank you. For those that have some time to give us just a few extra minutes, we'd like to show you our very easy to use programming software.
Absolutely. All right. So let's talk just a few minutes about the software. Now, ElkRP2 is our programming software. It is a free download from our website. All we ask is you create your username and password to the site. You can get the RP software. You can get any of the manuals and documentation that are available there. There's also firmware updates. If there's a particular manufacturer that we're now working with, you can update the M1 or the XSP and so forth to work with that new partner manufacturer. But I think you'll find that the RP2 software is really easy to navigate. It's a very powerful programming software language, but still very easy to use. It includes what we call conflict resolution. So as soon as you connect to the panel, it's going to check the differences between what's in your database or on your computer versus what's actually programmed in the panel, and it'll return those as conflicts. And you can resolve those by either receiving from the panel or sending data to the panel. So you have the option there to resolve those conflicts. The different connection methods, direct using an RS-232 or a serial to USB cable. Network connectivity through the C1M1 or the XEP interface, as well as being able to dial into a system using an external modem connected to your computer. You can use an external modem, dial in over the phone line, regular POTS line. You can access the system that way. And yep, the programming software. So what we have here is a very quick example of how to create a user. So in the software, I've pulled up user 2 here. You can highlight the information under the username, type in a new name. You can enter the 4-digit code or have the software generate a code for you. Select the user authorizations, the area that the code is good in. If you're using proximity devices, we could check mark this is an access credential instead of a code, for instance, a card or a fob, I button, numeric prox keypad. If you know the facility code and the card pin, those can be automatically entered here in the software. Or if it's a device that doesn't have your facility code and card pin, have the reader connected to the back of a keypad. We can manually learn in those devices at the keypad and then receive that information back into RP. Configuration of your zones. I've pulled down the hardwired main board. I have zone 1 pulled up. Simply type in the name for the descriptive name for the zone, in this case, main entry door. The drop down here allows you to select the definition, and we have a number of definitions to select from. In this case, it's your entry exit. I am using my end-of-line resistor at the sensor, so I would select type 0. Attributes, bypassable, force armable, enable chime, so forth. Those are all, you can just simply check those. For the voice description, the M1 has the 500-word voice vocabulary. If I click on the first option here and just start simply typing, you'll see the words that are in the vocabulary. Like in this case, I clicked in the first, I started typing main, selected main entry door. Now with chime enabled, and the chime is enabled on the keypad, when that door opens, the M1's gonna speak, main entry door. You can change that to any other descriptor there from the 500-word vocabulary to better describe the door, window, or access control point that's being enunciated, except driveway sensors. There's so many different things you can do with the M1 and the voice capabilities. Next, I've set up a keypad. In this case, the keypad 1 here is our main hall. Assigned it to the area. Selected the options, like for instance, LEDs off after 60 seconds and no activity. That way the keypad goes totally dark. So if it is near the main entry, maybe there's a window, you don't want anybody looking in to see the status of the system, select LEDs off after 60 seconds and no activity. If it's in perhaps maybe a bedroom, we want it to go dim but not totally dark, you would leave this option unchecked. Select the backlight level, so a lower setting here, say maybe a 1 or a 2. After 60 seconds, it's going to dim down. It's going to go to a lower setting that's not so bright, so it doesn't disturb anyone when they're sleeping. Now, depending on the style keypad, you either have function keys or F keys 1 through 4 or 1 through 6, depending on the keypad. These are your programmable keys. They could be your police, fire, medical. They can be totally automation related. It's really up to you. Each keypad is customizable depending on the area that it's in and what you want it to do. I'm going to talk about the rules real quick and just how easy it is to create the rules, but still how powerful the rules are. So a rule in the M1 system, a rule consists of a decision-making statement used to cause a particular action. In this case, the rule starts with a whenever. This is your trigger event. We also have and statements, which are optional. You don't have to have them. They're conditioning statements. And then our then statement, or the action that's going to take place, what you want happen after that. So a single rule would have a whenever and at least one then. You can have multiple thens. You can also have ands. Now the ands, let's see. Yeah. For instance, a whenever can be event or a time-based, and this is some examples of what trigger events we offer, like time occurrence, zone changing states, output changing states, keypad function keys, even the wireless RF keys on the wireless fobs can trigger event. Automation tasks. The big one is the security and alarm conditions of the M1. Those are trigger events as well. Like I said, we can have it based upon zones changing state, a switch is pressed, an hourly change, a minute change, even down to 1 second change. So in this case, whenever the front door becomes not secure, we have our then or our action or our command. We can turn on a light, turn on an output, speak a message, dial a phone number, send an email if you have the XEP module. You can have multiple then statements within the same rule. So each one of them would fire one after the other. So in this case, whenever the front door becomes not secure, turn the front porch light on. Now we can condition that rule even more with an and statement. Now these serve as a true-false type scenario. You can have multiple ands. Each one of the and statements must be true before it falls down to the next one. So in the example, we have whenever the front door becomes not secure and it is dark outside. So that setting there is under automation, sunrise, sunset. We select the latitude and longitude or a city near you so we can calculate approximately when sunrise and sunset will happen in that area, so that the M1 knows approximately when it's going to be dark outside. So in our rule, whenever the front door becomes not secure and it's dark outside, then turn the porch light on at that point. So it's not an all-day thing, it's only when it's dark outside. Any questions about the rules?
No, we don't really have any questions about the rules, and I'm sure that there's will be some that come up, and you can get in touch with us. You can see the email address that's on your screen now. You can also reach tech support by phone. You can find that information on our website. We also have a video where we covered a lot of rules examples and went into the ElkRP software in depth. And so we will provide that in our follow-up email for those of you that are looking for a little bit more on the RP and on the rules. We'll get that information to you. But I think that will get us covered for now.
All right. Well, listen, I certainly appreciate everyone's time today. Certainly appreciate Amy stepping in and helping us with today's webinar. And be on the lookout for that follow-up email. Any questions, please send those to either training or tech support at elkproducts.com. We appreciate your time and attendance today, and thank you so very much. Hope everyone has a great day.